All right, how's everyone doing? Cold. Yeah. I've lived in Pittsburgh for almost 10 years, and I don't think I've ever seen it this cold. I think tomorrow morning it's supposed to be negative like 3 or 4. Gross. Do y'all get outside? Like go sledding or something? No? Just stay inside. Yeah. So we have a little bit of catch up to do. We'll talk through what we're doing, but we're going to finish talking about exercise 1.2. So we did a little bit of work with numerical data, but we have a little bit more to do today. And then you've seen I posted a video on time series. We're just going to sort of touch base on that stuff in class. Videos are nice, but I think just talking about it in class is even better. So we're just going to breeze through that stuff. We're not going to do the exercise in class. The video is there for you for that. What I mainly want to do today is get started with panel data. This is my favorite data structure. So we're going to spend the next 2 class periods talking about panel data. We're just going to start working with it today. Did you all see this? Have I told you I had a baby recently? Have I used that joke before? No. So we went outside and played in the snow a little bit. This was her first snowstorm. I think this is just, look at that face. She looked confused and a little scared the whole time, but she's small enough. We just put her in a Tupperware container, attached a string, and pulled her down the road. So you all want to do some work today? How many of you would like to do some work today? Hands up. Okay, and then the rest of you are just here. I see that. I recognize that. It was a little hard for me to get out the door this morning, too. I think something about the cold. I don't know. But bring your enthusiasm. We're going to talk through a bit of what we've already covered, but we're going to do this just as a refresher, and then we're going to get started with some new stuff. I think what we're doing in part 1.4 today is really where this kind of thing gets exciting. I was talking to my wife about this a couple days ago. Like, I feel like the first couple of concepts are not that exciting, right? We're talking about just summarizing variables. Like, why do we do that? The reason is that once we start working with real data sets, like what you saw in the minimum wage example, we need to fully understand what we're doing or what's contained in our data set, right? Like, that's the big idea. And right now we're really just getting started with the basic tools of working with variables. So if you're feeling like we're going slow or these are not world-changing ideas, I agree with you, and that's on purpose. All right, so let's just refresh where we've been in part 1.2. This was the last thing we did in class. We did this last week on Thursday. The other thing is I've been at Pitt for almost a decade, and I think the number of snow days, I actually can't remember when we've had a snow day before, and we had 2 of them this week, which is really interesting. Y'all like the snow days? I don't know. I like the snow. I like being at home too, but I like being here during the day better. Okay, so this is what we did the last class, in our last in-person class. We talked about cross-sectional numerical data. So this is really just things that can be best described with numbers. And our main questions essentially are how numerical variables are distributed. So we're going to talk about random variables in part 3. You'll remember from your statistics class, we often like to think about just distributions of numbers. And so what we want to do is think about summarizing distributions of numbers. So the first tool we talked about was the histogram. When we have many observations, a histogram is really the right way to go to summarize numerical data. So what we did is we talked through little pictures like this. You told me that this figure was a little misleading because there was, the bins are not of equal size. So you can see here we have 40 to 55, which is 15 years. And then we had 35 to 39, which was just 5 years, which sort of skewed the way this figure looks. So when we're constructing histograms, we really essentially insist on equal size bins. And so we went through this little exercise thinking about the width of the bin versus the sample size and the noise. And it allowed us to think and visualize the data set more clearly. We also talked about some numerical summaries. So these are not like visualizations, but we like to work with the mean and the standard deviation. We'll come back to these ideas, especially in part 3, when we start really building models of inference. All right, so this was the figure. I think when I presented this to you, I didn't have the rest of the figuring involved, and you gave me some lecture points for bad slides. I fixed it, look. So we have mean, and we have, so it sort of tells us the center of the data, and then we have spread. And this is just a way of visualizing this. I'm not gonna ask you to do this kind of visualization of these numerical summaries, but this is just a way of showing the mean and standard deviation on a histogram. So we talked through some of these things, interpreting what these numbers mean, so to speak. Anyone? We're just talking about means. Tough crowd today. I mean, I wouldn't have laughed at that joke either, so I don't know. So this was really what we talked about with histograms, just our little summary. We use histograms to visualize continuous or numerical variables. You can do this with discrete numerical variables too. And then we want histograms to have equal size bins basically every time. And then we want to sort of trade off the resolution, so how small the bins are, against the statistical noise. And I mentioned this last class, there isn't a rule for how to do this. It really just involves picking the right bin width for your data set. So you're gonna have to pick what looks best for your questions. Okay, so this was the summary. And as you'll become familiar with as we work through the semester, I want you to think about working with data in 3 steps. What data are we working with? So what data are we selecting? What are the things we're doing to it? And then how are we encoding it? So when we're summarizing and exploring data, these are the big 3 steps. What we did here is we just looked at all Starbucks customers in our data set. And then with a histogram, what we're doing is counting the number of customers in each one of the bins. So this is what we call binning. And then the encoding step is taking the bin and putting that on the horizontal axis, and then our count of the number of customers in each one of these bins is on the vertical axis, like a bar. And we're representing that with a bar height. So this is the basic framework for thinking about histograms, right? We have these 3 steps. Every time we work with data, when we're summarizing data, we're going to be doing these 3 steps, just with lots of variations. We'll talk through a couple more today. Okay, so we walked through this exercise, and I think this is where we left off last class. We did this in Excel and not Python. So I want to sort of close the loop on these things before we start talking about box plots. This look familiar? Love the rousing enthusiasm. Was that a no?
It doesn't
It does look familiar, yeah. What a cutie. So the way we're going to get started today with our real work is to hop on over to part 1.2. I'm just going to remind you what we did in Excel. You don't have to do this in Excel today. We're going to do the exercise in Python. So I'm just going to download this data set. This is the customer profiles data set. And I just want to remind you of the steps. So in Excel, Excel often makes things complicated. In this case, creating a histogram is pretty straightforward. Tweaking the details of the histogram is when it becomes more challenging. But what I was looking for is just the distribution of ages in the customer data set. We could look at other things. But what I'm going to do is just create a histogram of ages for Starbucks customers. And what I did is just select the data I was interested in, go up here to statistical, and click on histogram. And this is the thing we submitted for the exercise last class. This was customer ages. And if we wanted to be specific here, we could say Starbucks customer ages. Okay, any questions here? And this is different from our data set in the slides. Here we're looking at just customers under the age of 40. So if the distribution under 40K. So if the distribution of ages for people making less than $40,000 looks different, it's because people making less than $40,000 generally tend to skew younger. So you make more money as you get older, and so here we're seeing sort of a younger skewed distribution. Okay, so this is, I think, essentially where we left off last time. I remember it being pretty tight near the end of class. So what we're going to do is pick this up, but in Python. I want to show you one thing that's generally a little more challenging to do in Excel, which is to change the bin sizes. So if I double click on the bins, it brings up the bin sizes here. And if I want to, adjust the width of the bins, I can go over here to bin width and then set this to some number. So if I wanted bin sizes of 2, I could do that here. It's not particularly challenging, but you have to remember all these little things to click on and drop down menus and all of this. Some people like this. In my mind, I prefer the code approach, where we just can always do the same things with code. So we don't have to remember the steps. Like I mentioned, I think last week, we like our scientific method to be reproducible. So whenever I perform steps, if you're doing anything that involves answering scientific questions, we like things to be recorded. If you're doing it, if you're doing all of these steps in Excel, you should be writing down each one of your steps. In Python, writing out code is exactly the writing out of the steps. So it makes your life a lot simpler in that way. Okay, any questions here? This is just to show you kind of the sort of a visual way of working with data in Excel. But we really don't spend a lot of time this semester in Excel. So the next thing to do is we're going to click on this notebook. And as we get started with this exercise in Colab, I want you to get in the habit of keeping a copy on your own computer. You're going to be submitting work generally throughout the semester, and it's good to keep a record of the work you're doing. So as always, go up here to File, and then hit Save a Copy in Drive. And that will copy my work, which is in the notebook here. And it'll copy it to your Google Drive. So I'm going to save a copy in Drive, and that's going to open this. So I'll just rename this 1 p.m. Okay. Any questions here? I also give you notebooks for your homework. So as you're working through your homework, I just like to give you the startup code just so it's as simple as possible. All right. So like we talked about last time, we're just going to load the basic imports. So this is just the first cell, and we just want the code to actually run. So I'm going to run this code, which you'll remember Python comes with a lot of things built in. It doesn't come with everything. So what we're doing here is importing some packages that we're going to use in this exercise. We're basically going to do a histogram in Python. And the first one is pandas. And as always, we're going to give pandas a nickname, PD. Then we have a couple of other packages that we'll often use. Now, the first thing to do is just to load the data. I've given you the file path to the Starbucks under 40K data set. So we're just going to try to compare the distribution of ages under 40K to those above 40K. So like essentially the full distribution to the subset. And we're going to try to figure out which bin works best for this data set. So if I run this, it loads the data set. And then if I just want to look at the data set directly, I can do that here. So I'll just put in customers. And I have this thing. So I've given some nice code in the slides, if you're interested. You can either, for now, use my code and copy it in, or we can just talk through the details of how to write this specific code to create a histogram. You're going to be doing something pretty similar in your homework. So you can think of this as like homework prep. Generally, the exercises are going to be pretty closely tied to the homework, so the homework doesn't feel disconnected. You can sort of think of exercises as homework prep. So I'm going to write a histogram here. Anyone know where we might start when we start writing code to write a histogram? Yeah. Yeah. So let's start with SNS, which loads the Seaborn package, and then the specific command for a histogram in Seaborn is histplot. I showed it on the screen already, so let's just write this out. Histplot. Okay, so we have histplot, and we have Seaborn, which is being loaded. What else might we do next? Like, what's the next step we do when we write out a Seaborn command? Like a visualization. Yep. Pete?
Yep. You can tell it where to find the data.
Yeah.
Customers.
Yep. So we need to tell Seaborn which data set to use. So let's write out customers. So we're just going to the first entry. So the first thing, but before before the comma is the data set. You can also be more specific if you like. I prefer to not write out this part, but you can say data is equal to customers. So you're just telling Seaborn specifically that customers is the data set. But you can skip this one. So you can just write in customers. And then what else might we do? So just thinking about first principles here. We're telling it the data set. We know it's a hist plot. What might we do next? Remind me of your name. Nicholas.
Tell it which specific
Nice. So Nicholas is saying, let's tell Seaborn which column to create a histogram from. And we want the histogram to be on the horizontal axis. You could try putting this on the y-axis if you like. I've actually never done that. But for now, we're just going to say x is equal to, and then we want to look for the column name that we're trying to bin, which in this case is age. So just like in Excel, we selected the data, and then we told it to create a histogram based on that column of data. Here, we're just telling it to use this column as the histogram. Okay, so any ideas what would happen if we ran this? Have you tried? Yeah.
Would it give you like every single individual age?
Let's try it. Remind me of your name?
Alex?
Alex. So Alex is proposing that it might just create a bin for every age. Did it create a bin for every age? No. That's a pretty good guess, though. That might be like a first guess. It's discrete numerical, so it's there's no, it's only integers. So maybe we would expect it to create a bin for every age. Here it looks like it's creating bins by itself. It's just decided how big the bins should be. Excel did this too. Behind the scenes, there's some decision process inside the hist plot, which automatically creates bins. But we can do a little better. There's this property called bins, and then we can just tell it what bins to use. So one thing we could do is just write out bins. So we could say 15, 20, 25. If we just ran this, we just get a few. We actually want lots and lots of bins. Anyone know what we do here to make our lives simple? Yeah. The width, yeah. Yeah, very nice. Remind me of your name? Micah. So Micah is saying what we're going to do is use one of these built-in Python functions to just create a list of numbers for us. So I'm going to show you what this looks like. So I'm going to say range, and I'm going to say I want the lowest age to be 15, and I want the highest age to be 100, and I want this to be in increments of 5. So if I print this out, it's not going to say much, but if I make it a list, you can see what range is doing. It's creating a list of numbers for us very nicely. So we don't actually have to go through and write out all these numbers if we know how to use range. You can see it doesn't include 100, so it just goes up to the last one. If we made this 101, it would include 100. So all I'm going to do is just copy this over and put this as the bins. And what this is allowing us to do is easily create our own bins. So we've specified what the bin sizes are, and then Python is going to use the bins we've told it to use to create bins for ages. Okay, any questions here? Quick poll. I'm curious. This will change as the semester goes on. How many of you prefer Excel to create histograms? And how many of you prefer Python to create histograms? Okay, interesting. Even split, or roughly. Maybe a slight skew towards Python. I think this is one of the cases where they're maybe about equally challenging. But in your homework, you're going to be asked to make a couple of different bin size choices. So, I mean, one thing we could do is change the bin sizes. And Python makes this really easy. All I'm going to do is change 5 to 2. And here you can see I've created a new histogram, but with bin sizes of 2 instead of 5. We can go all the way down to 1. And here you can see this is very spiky. I don't prefer this one. I think 2 or 3 is pretty good. This might still be a little spiky. Y'all like this one? Anyone want to make a case for a good bin width?
Or
4?
4.
I think this is like generally the right read zone. Like you could pick maybe 6 or 7 or 4, somewhere around here. Yeah, nice. The other things we might want to do are create summary statistics. We're going to spend a lot of time working with mean and standard deviation a little bit later. Y'all are probably very familiar with these things. Oh, and then last thing here, when you're submitting exercises or homeworks, I'm going to ask you for a PNG file specifically. And all you have to do to create that from the figure is just right click and then save image as. And then it'll just save it into your downloads folder. And I have this nice figure we just created. Any questions here? Yeah.
Have you figured out what wasn't working with the save fig?
Yeah.
Feature?
Oh, that's right. Yeah. So I had, remind me of your name. So Evan's looking at the slides and seeing we have this save fig. I'm not sure why this seems to not be working with Colab. It's worked in the past. If you try running this code, the thing I would expect it to do is to save the figure into your Google Drive. But we're gonna put this on hold for a little bit. You're just gonna have to right click on the file. That seems to not be working. Okay, any other questions? Yeah, Micah. Yeah.
For the save thing, if you go to your files and look on the left side of the lab, it shows up there, and then you have to download it.
So let's try that. So Micah's saying if you put this in a code cell, run this, and then in files, you should have it here, which is true. Yep, so you can store it here if you like. The way I access this is just by clicking on this files icon, and that was here. You still have to download it, so whether or not that saves you time, that's your choice. Any other questions? That was good. Thank you. I would give out lecture points, except lecture points are for getting answers wrong. Okay, so this is the histogram. The last thing we'll do before talking about box plots is doing some numerical summaries. So sometimes, generally I think the right place to start is with a visualization, but you've become familiar with mean and standard deviation. And I just want to show you a little bit about how we do summary statistics in Python. So all I'm going to do is write out customers, and then I want to look at the column for age. So this is just the syntax here. So if I run this, I get just the column for age in the customers data set. But I can easily get mean. So if I just write dot mean, this gives me the mean of the age column. It puts this thing around it, which is a little bit annoying, but this is the basic idea. So we can just easily get a summary statistic using Python. We can do lots of other things, like customers standard deviation. So std parentheses gives us standard deviation, and this tells us about the variability in ages in our data set. Any questions here? So nothing truly like mind-blowing about this, except we don't have to do a bunch of stuff with our calculators. Python handles a lot of these back-end kind of things very nicely. Okay, so I would say on the low end of interesting, but these are some of the core sort of skills that are required. Okay, and I've given you some code here just to work through this. So, yeah,
So I think I missed you just had
yeah. For you're saying in this. So yeah, all I did is find the age column in the data set, and then it's dot mean, and then you put the closed parentheses. Yep. Remind me of your name? Zayas. Yeah, thank you. Any other questions here? Yeah.
I ran it after shot parentheses and noticed there was a why do you have to put them
The parentheses.
there? Yeah.
Yeah, this is one of those things with Python. This is telling it that it's a function. So it's running a function on that column. If you don't make this a function, it doesn't really know what's going on. I think this is a little unfortunate, sort of on a like a syntax level. I wish we didn't have to put those things, but that's just how it is. Yeah. Remind me of your name.
Claire.
Thank you. Any other questions? Okay. I hope this conveys to you, even though this is like conceptually not mind-blowing, hopefully this conveys to you the power of code. We can do a lot of things very simply and very nicely using code. This is really just scratching the surface. Code gives us just like a much better perspective on doing things systematically. All right. So this is all working with data sets with lots of observations, right? Like we were on the order of thousands. Histograms are very nice in this context, right? Like when we have lots of data, histograms really are the right way. But I'm going to show you an example when histograms aren't necessarily the right approach for summarizing numerical data. If we have really just a few observations, histograms, because we're binning and then counting, histograms are sometimes not the right approach. So what we're going to do is talk about box plots and strip plots. I think box plots on their own are fine, but when we have a few observations, box plots and strip plots together gives us a lot of extra ability to communicate with figures. So here's a histogram. I had this data set, coffee consumption per capita among some coffee importing countries. And this is in 1999. And I think this is fine. This is pretty good. Anyone have any quibbles with this figure? Quick pedantic side note. I did not include a vertical axis label. How many of you are okay with this? How many of you would prefer a vertical axis label? Okay. Y'all are wrong. The vertical axis label is fine. I just generally tend to leave them out for histograms. So apologies. You're just going to deal with that this semester. So this is nice. One of the problems with histograms, though, is you can't actually see the specific like values. We're counting based on bins, which is really nice to get a sense of the distribution. But if I care about specific values for my observations, this histograms obscure the specific values. So what I'm going to show you is a different way of visualizing coffee consumption per capita. There are lots of questions like this that histograms make challenging to interpret. So like, which country drank the most coffee in 1999? And if you're just looking at this, you don't know how much coffee the maximum drank, and you just know that it's in this bin. So what I'm going to do is show this histogram. You all have seen histograms before, and I think most of you have actually created histograms. What I'm going to do is just talk a bit through some of the details of what histograms tell us. The first thing is the median. So this middle vertical line here represents the middle value. So we have half of the data above this middle bar and half below. So this is the median. This lower bar is the minimum. So this is the lower end of the whisker, which tells us the minimum. This is the upper end of the whisker, which tells us the maximum. So all of our data is included somewhere on this line. So the entire box, all of the data is somewhere within this box plot. We also have this middle box, which is where box plots get their name. This contains 50% of the data. So on the horizontal axis, 50% of the data is contained within this box, which tells us 25% of the data is on this side and 25% of the data is on this side. We also know that 25% of the data is between this lower bar and the bottom bar, the lower whisker. So 25% of the data is here, 25 is here, 25 is here, and 25 is on that side. These are what we call quartiles. So I think quartiles in some ways make understanding our data a little bit nicer. So like depending on your question, just seeing the quartiles can be nice. It's not a big idea, but sometimes a box plot can be a better way of showing distributions if you care specifically about these quartiles. But I think really where box plots get their power is when we add a strip plot. So here I've just actually taken each one of the observations. So we have coffee consumption per capita for a bunch of countries, and I'm just plotting as a point the coffee consumption per capita for that country. And then I've just done this for every country. So what the box plot is doing is just giving us a sort of a summary of this underlying distribution of data. So this bottom country, I believe, we'll get to this in a second, but I believe this is Russia, doesn't drink a lot of coffee per capita. And so we can just see that in the actual data point itself. One thing to note about the vertical dimension here, sometimes when we create strip plots, we add what we call jitter. So there's, it seems like there's a vertical dimension to the data, when in fact, this is just to give some extra dimension to be able to see the data points better. So this vertical dimension is actually meaningless when we add jitter. So there's one dimension, and then we're just visualizing the distribution in this way. Any questions here? I've heard some people argue that box and strip plots are, when they're combined, are the best visualization of numerical data. But I think it's a little more nuanced than that. I think sometimes a histogram is a better way to see data. But when we're dealing with small data sets like this, we can ask specific questions about our data that a histogram makes hard to see. So like I mentioned, these are just the quartiles. So minimum Q1, just the point where 25% of the data is below it. Median Q3, where 25% of the data is above it. And then the maximum. Okay, so I'm going to ask you a bunch of questions. You're going to tell me some answers, and then we're going to create some box plots at the end. So first question, which countries consumed more than 8 kilograms per capita? So there are a couple of things you're going to be doing when you try to answer this question. First is find a process. Like, how are you using the figure to answer this question? And then answer the question and tell your neighbor. Looking for a number. Okay, you gave a number to your neighbor. Also give a compliment, like This is hard to do. Okay, y'all are not into this. It's nice seeing all of you today. I'm glad you're here putting in the work. You seem dedicated. Is that a nice compliment? Okay. Someone want to give me a number? Yeah.
I said 6.
6. And why is it 6?
Because
Like, what's our process?
we're looking at more than 8, and the horizontal axis gives us 1 kilogram, like per number. So I was like, what's more than 8? And there's 6 red dots.
Nice. So all we're doing really is looking on the horizontal axis at 8, and then just counting up on the upper side. It turns out there are 6. I'm sorry, remind me of your name. You've told me so many times.
Zach.
Zach, that's right. So Zach is saying 6. How many of you got 6? Okay. Good job counting. How about some more challenging ones? So this is just a picture of the solution here. Just we're highlighting the relevant subset. Which countries consumed the most coffee per capita, or country? I think there's going to be one. First, use the figure, find a process, and then try to identify which dot. Like, you don't know which data, which country it is, but try to find which dot. Maybe this is an easier question. Tell someone what you did with the snow this weekend, or this week, and then find a process.
Should I stay inside?
Yeah, maybe we went to like 2 days.
What do you think for that?
Okay. So how did you find the maximum? Yeah. Nice. So yeah, so these are pretty simple questions, right? All we're doing is looking to the upper end of the graph, finding the data point that's largest. So it's going to be this one. We can also tell by the upper end of the whisker. So the upper whisker sits directly on top of the largest data set, the largest data point. This is by construction. Like, this is exactly what the box plot is doing. Okay, what if I made the mini exam this easy? Would you like that? Okay, so we can find exact values given to us by the quartiles for these things. Just for some information here, in 1999, Finland, of coffee importing countries, Finland consumed the most coffee, which is pretty interesting. It's a very cold country. I drink more coffee in the winter than I do in the summer, so maybe that's related. Okay, what about some more challenging ones? Here, I'm just showing you the country that consumed the least amount of coffee per capita, Russia. We can find this value exactly the same way we did with the maximums, except instead we go to the minimums, right? This is what a box plot and strip plot does for us, is allow us to see these points directly. So this one's maybe marginally more challenging. Let's just take like 10 seconds here. Tell your neighbor how you would find the median. Okay, someone want to tell me how you find the median? Yeah.
Just look at middle line of the box plot.
Yeah, so middle line of the box plot gives us exactly the value of the median. And if we were trying to select the data point that was closest to the median, we would just try to figure out which one that was. I think it's maybe this one on the bottom. Turns out it's the United States. I am an outlier. Actually, I wasn't drinking coffee in 1999, but turns out it's us. Any questions here? All right, for the sake of time, let's answer maybe a slightly more challenging question. Which country consumes more than exactly 25% of countries? And again, not looking for a country, just looking for a point on the figure. 10 seconds.
So like 3 like it's I don't know.
Okay. Hands up if you think it's something like 2.8. Hands up if you think it's something like 4.1. Hands up if you think it's like 5.5. Nice. So greater than 25% of the data we're looking at this end of the box plot. Okay, so I feel pretty confident you can work with box plots. The mini exam will not be this easy, unfortunately. Maybe it will, but it will not be these questions. So it's Slovakia. Anyone been to Slovakia? Yeah, me either. I bet it's nice. And then if we're looking at exactly 75% of countries, this is the Netherlands. All right, so here we have these 5 countries, each representing one of the quartiles. So this is essentially what box plots are used for. They give us sort of a visual summary of the quartiles directly. And the strip plot on top of that, particularly when we don't have a lot of data, is really nice for just seeing what the values are themselves. Another similar kind of distribution visualization to a histogram. Except here, I think this works a lot better when we have small amounts of data. Okay. So what did we do here? Well, we were just selecting all the copy importing countries in 1999. What we did is actually just go through and calculate the different quartiles, and then, which is a transformation, so we're actually constructing the quartiles themselves. And then what we did is encode the quartiles as the box positions, and then for the strip plot, we were just plotting the values themselves on the horizontal axis with our strip plot. Any questions about this? So I think for the sake of time, we're not going to create box plots in Colab. I don't want to spend a lot of time on this, but let me just show you a bit of what we can do. I'm just going to run through this pretty quickly. I'm just going to copy over the code into the exercise. This is the coffee consumption per capita data set. And if I want to create a box plot, all I have to do is just say SNS, so I'm calling Seaborn. I'm just going to tell it to use a box plot, so box plot. I'm going to use the coffee consumption per capita data set, so this is coffee. And then I'm going to say I want the variable to be on the horizontal axis. So this is coffee 2019. So this is the variable we're looking at. And I'm plotting that on the horizontal axis. This is pretty nice, but it's not great yet. You can see there are these outliers. I mentioned this when we talked about time series, but I'm going to say whiskers. I just want that to include everything from the 0 value to the 100. Okay, so this is a box plot. We can also set up the strip plot. So if you want to write this out, I think at this, we've done a couple of examples like this. I think you probably know the process. What would we do first? SNS. And then what do we do next? Strip plot. And then what do we do next? Coffee. And then X is equal to coffee 2019. Do you see the pattern? I think this is very simple. I don't think Excel, at least I'm not familiar with how to do this in Excel. So this is one of those tools that we've now sort of crossed the threshold into Python being much, much simpler. Okay. There's not a lot I feel like we need to talk about here. Yes?
So is this just overlaying the two plots on top of each other?
That's right. Yes, we took the one and we printed it out. Then we added the second line, which then kind of puts them together.
If you wanted to mess with the x-axis, would you have to do it for both?
Good question. I think if you change this, it'll get wonky. Yeah, we don't really want that. If we wanted to put this on the y-axis, so sometimes box plots are nicer on the y-axis, I would actually just change both of these, the y to be the same. So I think if you don't have them on this with the same y or x, then it gets wonky. You could set up just a strip plot if you want by just running the strip plot on its own. But because they're in the same cell and we run them together, it puts them on the same figure. Any other questions? All right. So then I'm giving you some code to do quartiles in the slides. Here you can get minimum, maximum, and then some of the quartiles. There are lots of little functions like this for summary statistics. We've talked about mean, we've talked about standard deviation, and here we've talked about the 5 quartiles. This will be useful in your homework. I'll ask you similar kinds of things. And this is intended to be a nice reference. Any questions before we close out? 1.2. All right. So here we talked about numerical variables. We focused on cross-section. In 1.3, we're crossing over into time series. But here we're just looking at cross-section, so all at the same time. We've talked about binning, we've talked about means, standard deviation, and quartiles. And then the main visualizations we've worked with are histogram, box plot, and strip plot. So be familiar with when to use which and how to identify which summarization tool is the right one for which context. These are the kinds of questions I like to ask on mini-exam 1. All right. Y'all ready to talk about time series? Well, unfortunately, we're not going to spend a lot of time on it. I posted the video to the course page. So I think you all saw this. This was just me talking through the slides. And then we have exercise 1.3. But I just want to touch base about these things. We'll spend like 2 minutes, and then we'll start talking about my favorite data structure panel. Okay, so time series, the main distinction with time series is that we're switching over from thinking about simply entity indexes, where we collect many entities at one point in time. So the index variable is unordered. There's no inherent order to the index. Now we're switching over to thinking about many points in time, but one entity. So here we do have an order. So we can sort of think of our data as being in sequence. So that's the big change. And then we just walk through what time series data looks like. Here I have one numerical variable in time series. through time. And then we just think about, different ways of trying to summarize time series data. This first one with a histogram is just generally wrong. Sometimes you care about histograms of time series data, but usually we like to think of time series data as being sort of one entity through time, and the way we sort of visually communicate this is with a line graph. So we have time on the horizontal axis, and then the value on the vertical axis. Then we can sort of think about trends and subtrends. One way we often visualize subtrends is just with background shading. In the exercise, we walk through creating these things. So as you're now becoming familiar with Seaborn, it's just SNS dot whatever the kind of visualization tool you're interested in. And then you put in data as the first entry, X for your X variable, and then Y for your Y variable. And it's really just that simple. So the basic steps here are looking at specific copy prices, ordering them on the horizontal axis, and then positioning Y as the price. Okay, and then we talked about longer periods of time. I walked through this inflation adjustment procedure. How many of you are interested in macroeconomics? Okay, this is something macroeconomists do a lot. I'm not a macroeconomist, but if you're into macro, even in your intro macro class, you probably did the math for inflation adjustment. Here we can just do it with a computer. No macroeconomist is sitting down and writing these things out. Every macroeconomist is doing this with a computer. And this is the procedure we walk through. So when we're thinking about long time periods, we just want to make sure that all of our prices are comparable. And so that's why we do these kinds of real price adjustments. Okay, and so we walked through this in the exercise. And then we talked through using box plots and strip plots like we just introduced in part 1.2 to think about seasonality. So sometimes we care about the sequence, but often we want to look at trends within the trends. And so one thing we can do is think about whether there's something going on with seasons. So what I did here is just create a multi-box plot, and then in the slides I talk through some questions like this. Okay, so a bit of a summary. We like line graphs to show numerical variables through time. We can use shading to highlight subtrends, and then multi-box plots sort of allow us to show the distribution within sort of like seasons, so like subtrends. Okay, any questions here? That's all on the course website. Take a look at that. You'll create line graphs and box plots. So what I want to introduce briefly today, in the last 15 minutes of class, is this last data structure. And this is the one I get most excited about. It's the most complicated, but it's also, I think, by far the most interesting. And this is really where we start making our transition into thinking about relationships between variables. So you'll remember at the very beginning of class, we did this thing. We looked at this minimum wage study. When I think about this class, I try to, we use the minimum wage study as a motivating example, because these are the kinds of things we do with this, with economic data, is try to inform economic thinking using real observations, right? Like theory tells us some things, but we have to validate the theory using observation. That's the scientific method. We make a claim and then we go out and test it. And this, I think, is a great example of that, right? We make a claim using theory, and then we try to go out and test whether our claim is correct. This is a notable one because the simple theory was not correct, or at least we don't think it's correct. So if you remember back to class 2, it was like a Thursday of the first week of the semester, we talked through this minimum wage study. We said we had 2 periods, and we were looking at the difference in employment on 2 sides of the border, one that raised the minimum wage in New Jersey and one that did not. So we had Pennsylvania on one side and New Jersey on the other. This is the sort of the results figure, which is the change in sort of employment levels on both sides of the border. We saw New Jersey's went up slightly, although I don't think they were able to distinguish it from zero, from no change. But Pennsylvania's went way down because of the larger economic environment that was going on at this time. So the important thing here, you'll remember, is that New Jersey performed much better than Pennsylvania did in a bad environment, a bad economic environment. They were able to conclude New Jersey did not lower its employment when the price of labor went up. So quantity demanded of labor did not go down when the price went up, which contradicts sort of the simple theory of minimum wage we often talk about in our early classes in economics. The way they did this was to measure at 2 points in time. They measured 2 states at 2 points in time. So this is 2 entities. So they had Pennsylvania and New Jersey, and they had 2 points in time, before the minimum wage and then after the minimum wage. So what we have here is sort of a little snippet of the data set. So FTE is just the level of employment. Here I have state. Here I have wave. So this is whether it's before or after the minimum wage was implemented. And then here I just have a measure of the store. So I just want to make a few observations about how this data set is structured. First, I have the same store both before and after. So this is my index variable. And I have the same store before and after the minimum wage went into effect in New Jersey. So I have the same entity, but multiple times. So at multiple time index variables. So then wave is just a measure of time. So this is our time index variable. And then I have state and FTE. So you can probably already tell, this is not cross-sectional, right? We're not measuring observations at one point in time. So definitely not cross-sectional. And then this is also measured across multiple entities through time. So we do have multiple time periods. So we have wave 1 and wave 2. But it's measured in these multiple time periods for many entities. So this is definitely not time series either. So you can see what this data set, this data structure kind of allows us to see. We get to track multiple entities through time. And that's very useful, as you can probably already tell. This gives us essentially time series data for many entities. This is the kind of data set I used in my dissertation. It's the kind of data set that was used in the minimum wage study. It's very powerful. It's powerful enough that we're going to spend 2 parts on it. Today we're going to talk about what we call long format panel data, which looks like this. And we'll talk about this, how that's defined in a second. But like I just talked through, panel data tracks many entities through time. That's what differentiates it from time series and cross-section. It's essentially just like squishing time series and cross-section into one data set. So we stored in 2 formats, long and wide. Long format data looks like this. So we have, many entities. So we have a bunch of different shops. And we have well, I guess my little data snippet only has one shop. But trust me, there are many different shops. And then we have many different time periods. And what I'm doing here is just recording different observations through time, but across many different coffee shops. So the main characteristic of long format panel data is that each observation is a separate row. So each time I observe the transaction quantity, that gets recorded as a separate row. So we have shop indexed by I, we have hours indexed by T, and then X is our quantity. Any questions here? We're going to talk about wide format next class, which is a different way of recording panel data. This sounds so in the weeds, but as we start working with these things, there's a good reason why we talk about these things separately, which we'll get to. Okay, so let's just talk through a few things. I have a nice little data set here, and this is on coffee sales. So I have a bunch of transactions from 3 different coffee shops. And we're going to look at transactions by coffee shop through the day. If we're thinking about the demand for labor, so this coffee shop is trying to hire a new barista. What we're trying to do is figure out maybe which coffee shop and which time of day is the busiest. So where should we hire this barista? Okay, so this is our question. You manage 3 coffee shops and you're thinking about where to hire. We have this data set. Let's try to inform our decisions using this data set. Okay, so this is the data set. I've already showed this to you, but this is generally how it's structured. We're actually going to get our hands on this next class, but I want to walk through this visually before we actually start working with the data. So I think it's generally the case, if you just look at a data set, it's really hard to know where to start. Like, which coffee shop should we hire? You can't see that just by looking at this data set, which is the main reason why we do summarization. Which coffee shop is the busiest? Where should we hire? Impossible to tell without summarization. Okay, so I'm going to ask you some questions. Hopefully these are a little more challenging than the box plot ones. So I think this is a very nice way of summarizing this kind of data set. All I've done here is just count up which coffee shops, where transactions are happening based on coffee shop. So this is just, I'm going through and counting. So this is just a bar plot. And I have the 3 shops, and I have transactions by count. So if you're looking at this, I think you can all tell which coffee shop is the busiest, right? Very simple to tell. We've done the summarization. This is much easier to inform our decision making using visuals. Okay. So first main point, do the summarization to tell you about these things. So if we were thinking about this question, so we know transactions by coffee shop. So we've gone through and done the counting. What about this question? What time of day is the busiest? I'm curious what visualization tool you would use to answer this question. And then once we do it, we'll try to answer our subsequent questions. Anyone have an idea? Yeah. Histogram. And why a histogram? Nice. Yeah, remind me of your name. Lucius. So Lucius is saying we're going to create a histogram. The horizontal axis is just going to be hour of the day, and then we're just going to try to count up the transactions by hour of the day. Yeah. So it would look something like this. So again, if we're just looking at the data set, it's impossible to tell what time of day is the busiest, so we create a histogram to inform that decision. So I would say morning, right? Highest count makes a lot of sense. So maybe second to last question of the day. We said coffee shop A was the busiest. So coffee shop A was the busiest. And then we also said morning is the busiest. So my question to you, we'll take like 30 seconds here. Does this mean coffee shop A in the morning is the busiest? If we're trying to hire specifically for a shift, where should we be hiring? Take about 30 seconds here. Maybe make a wild claim to your neighbor, and then maybe make a less wild one. Okay, no one took me up on that. You didn't like the compliment thing either. No. Should we be hiring for coffee shop A in the morning? That's the question. All right, I've either put you all to sleep or this is an easy question. How many of you think coffee shop A in the morning is the busiest? How many of you think it's definitely not the busiest? And how many of you think we don't have enough information? Correct. We actually don't know that coffee shop A in the morning is the busiest. We know that most transactions happen at coffee shop A, and most transactions happen in the morning. But it may just be that coffee shop A has a much larger demand in the afternoon than the other coffee shops, which turns out to be the case here. So this is, you're going to critique my figure in a second, but this is one way of visualizing the distribution of transactions by 3 coffee shops. So remember what we're doing here. This is a panel, and what we have transactions for each coffee shop at each time of day. What I'm doing here is creating an overlaid histogram. So we're just going to use the same idea we've used, a histogram, and then just add some transparency so that we can see all 3 things and put them all on the same figure. If you hate this figure, you're in good company. But this is the tool we've been using, so let's try to answer our question with this. So, turn to your neighbor and tell them which coffee shop has the highest demand at which shift.
It starts like a CZ and moves to the color.
Okay, someone help me out here. Where should we be hiring? Or like, which shift has the busiest peak?
So C from like 8 o'clock to 11 o'clock.
So here maybe. Yeah, so we have coffee shop C in green, and coffee shop C seems to have the largest demand in the morning. Yeah, any other ideas here? So we should be hiring at coffee shop C in the morning. Is that what we're saying? Or are there other things we should be considering? So this tells us the demand for baristas, right? Like there are a lot of transactions happening in the morning at coffee shop A. But with this information alone, we don't know how many baristas are there already. So it may be that there's differences in the supply of labor. All we can see here is the demand for labor. So that's one thing about this figure. Do you all like this figure? So the last thing we're going to do is talk through how we can improve this figure. We've worked with histograms, a big part of what we did today. I think this figure is very, very hard to read. I use this on purpose as an example of a bad figure. Any ideas for how we can improve this? Yes, Nicholas. So what we call faceting. So instead of putting them all in the same figure, we can actually split them out, which we'll do in a second. Any other ideas? Is that a hint? Nice. So sometimes we would want to use faceting where we split the histograms out. Faceting is really nice for just seeing the distributions separately. Sometimes we want to make comparisons between distributions. And in that case, we actually would, instead of plotting everything, the whole area of the bar, we would just draw a line over the top of the histograms, which pulls out a lot of the clutter. Yeah. So the first one is faceting. If we were to just plot these things out, I think it's easy to see each of the distributions separately. Which shop has the most consistent traffic throughout the day? Well, we just sort of talked about this. This is coffee shop A. Most transactions happen at coffee shop A, but it doesn't have the biggest spike in the morning. But then our original question was, which one has the biggest spike in the morning? And I think faceting makes it a little bit harder to see the answer to that question. So instead, what we can use are a multi-line plot like this. And I think this one's probably the easiest way of seeing this. All right, no exercise to turn in today. We'll pick that up next class. Nice to see all of you again. I have office hours tomorrow. Feel free to drop in. Good luck on the homework. Let's see. You have homework 1.2 and 1.3 due tomorrow. Hey.
I have a question. So for homework 1.3,
Yeah.